Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So now let's move to the last part of this chapter. That is what we call common drain. So for your MOSFET amplifier, so you have two parts. One is what we call common source, and another one is common drain. So how do you know this is common source? This is source, gate, and drain. Your Vout is located at the drain. But for your common drain, your Vout is located at your source. How about the value? For your common source, your gain will be negative and more than 1. Means that your output is amplified and inverted. But for your common drain, it's like a buffer where you have an input and your output will be almost the same. So if you recall back your BJT, so inside your BJT, you have what we call common emitter, and here we call common collector. So the same for common collector and the common drain, your gain is almost equal to 1, where we call here emitter follower, or here is a source. The other name here is a source follower. Okay, so that's why we say here the gain is positive. Okay, so let's see how is the circuits looks like for your common drain. So as I mentioned just now, the other name is the source follower. Why? Because the gain is almost equal to 1. So it's like a buffer. So how you identify this is a common drain? So this is a gate, source, and drain. So your Vout here is located at the source. Vout here is located at the source. So this is what we call source follower or common drain. So the steps are, you need to change this one to number 1, AC equivalent, and go to the small signal equivalent, and then you need to derive the gain. So we'll see how we're going to derive the gain. Okay, so this is the common drain of the circuit. So first step, what you need to do is to change to what we call AC equivalent. So what happened at the AC equivalent, capacitor will be shorted, your VDD will be directly ground. So let's redraw. So you have here RSI, and here is your input voltage. R1 and R2 are parallel, and then you have your NMOS, and here is RS, and your drain here is directly to ground. Okay, so where is your Vout? Vout is located at your source because this is a common drain. Second steps, you need to change your NMOS to what we call hybrid pi. Okay, so how we start with the hybrid pi? We have 3 pin here. So here is G, S, and D. Between G to S, you have what we call small v, small g, small s. Between D to S, you will have a current source that is called GM. It is a dependent current source, so it depends on your VGS. Okay, so let's say this question is having R0, the VA, so you will have here R0. And the last one, where is your drain? Drain will be grounded. Okay, now let's move to the source. So at your source, you will have RS. Okay, and this is where the Vout located. This is your Vout. Okay. Next, from here, at your gate, so where is your gate? We have R1 parallel to R2, and then you connect it to RSI, and then Vin, and all here are grounded. So this is what we call small signal equivalent for common drain. Okay, look at this part. Your Vout is at the middle, Vin at the most left. So your aim now is to move your V out to the most right. So what you need to do now is the same with the common collector, where you are going to swap these circuits. Okay, let's try to redraw now. Okay, now what we need to do is to swap the circuit. Swap. Okay, how are you going to start with the swap? So it's like a common collector. So you need to redraw again. So D to S, you're going to change between D, S, and here is G. So now let's rename it. G to S, you have what we call VGS. Between S to D, you still have the current source, but now it's pointing upward, become GMVGS. Okay. For this circuit, usually your VA is given is VA is 1 over lambda, right? And usually your lambda will be equal to 0. 1 over 0 will become infinite. So your R out here usually become open circuits. Okay. At your source, you have what we call V out, and then you have RS. Okay. At your drain, it is directly grounded. Okay, done. And then we go here. This one is R1 parallel to R2. And then you have RSI, and here is your V in. So this is the complete equivalent of the common drain. Now you need to rename here. Here is your R out. Here is your R in. Okay. And now this is the equivalent of the small signal equivalent for the common drain, where you're going to start the derivation of your gain from these circuits. Okay. Okay, so now let's start the derivation. Okay, for example, if the circuit is given lambda some value, okay, so means you need to have VA, and that means you have R naught. So let's just add here. We have here R naught. Okay, so now how are you going to start with the derivation? First is your V out. V out. What is your V out? Ohm's law. I out, R out. I out, what is your I out? This is the current source, right? So means it having the same direction. So your current source is the output current. Multiply by your R out is your small r parallel with RS. Okay, then we are done with the output. Now let's move to the input. So your input here is, this is your V in, and here is your VGS. Okay, so for your input, so here is V in, right? We call here VI. The voltage at this point will not be the same here because they are not parallel. So you need to rename another value here we call V in. Okay, plus minus V in, because they are not parallel. So what you need to do is you need to have the KVL from here until here. Until here, and then here you have a current source, right? So means what, this is what we call super mesh. You're going to ignore this current source and then move towards here. Okay, you know here is your V out, and they are parallel, right? So this point is also V out. Okay, so let's do the KVL. From this point go up until here. So KVL from here is minus V in plus VGS plus here is your V out equal to 0. Okay, so your V in is equal to VGS plus V out. What is your V out? Is the equation before. So you just replace VGS plus GM-VGS are not parallel to RS. So you can get your V in equal, you take out your VGS because here they have the same VGS, 1 plus GM are not parallel to RS. So this will be the equation for your V in, this will be the equation for your V out. Okay, the third steps is you're going to have your voltage divider. Why? Because the voltage, your AV is actually not V out over V in. This is VI, right? It's V out over VI. So we want to see the relation between V in, this is your RS, and the whole here is your R in, and the voltage drop at your R in is your V in. So as usual, your V in is actually R in divided by R in plus RS multiplied by V in. So this will be equation number 3, number 1 and number 2. So what you need to do now, you need to find the gain. So what is your gain? AV is actually V out over V in over VI, not V in. Okay. So your V out is GM VGS R naught parallel to RS multiply by what? Multiply by 1 over the whole here. So means 1 over VI, right? So it's become 1 over V in R in divided by R in plus RS. Now let's look what is your V in here. V in is from the equation number 2, right? So finally you can get here GM VGS R out parallel to RS divide by, because this is 1 over V in, VGS is from equation number 2 here, 1 plus GM R naught parallel to RS, and then the voltage divider here R in plus RS. So then you can take out your VGS. So this will be your final derivation of your voltage gain for the common drain. Okay, so from the slide here is the same as before. So here where you can get the AV, the voltage gain for the common drain. Okay, so next video we will move to the output resistance of the amplifier. So this is almost the same with common collector, where you need to derive what is your output resistance. So the output resistance of the amplifier is not the same with R out parallel to RS, because you're doing the swap of the equivalent circuits. Okay, so if you look at this formula, the gain here, what is your R in here? R in here is just pointing from the towards here is R1 parallel to R2. So we don't have any RIB for the MOSFET because you only have the voltage drop here, not the R pi. Okay, so wait for the next video, the last one, how to find the real R out for the common drain. Okay, see you in the next video. Assalamualaikum.